Alright, so let's talk about Saxon Lesson 71 for parallelograms. First, I'm going to go over some important vocabulary. We've already talked about the word perpendicular before, but I just wanted to mention it again to make sure we all remember what we're talking about. So perpendicular means that lines form a right angle. When we are talking about the perpendicular height of a polygon or a shape, it is a line drawn from the top or the vertex of a figure to the base opposite at a 90-degree angle. So first of all, lines that cross at 90-degree angles are perpendicular. So these two lines are perpendicular. Perpendicular height comes from my flat base, makes a 90-degree angle, and comes up. Supplementary angles. Those are angles that add up to 180 degrees, or the angles add up to a straight line. So if I take a protractor on this straight line right here, right about the middle, then if I were to measure from here, the beginning of my angle straight line, and count it all the way around to where it ends, I'm going to get 180 degrees. But if I just wanted to do the angles of A and B, so A would start here. I have my little corner in the vertex, and it comes out here to about 155 degrees, give or take. B would be from 0 up to about 25. So I would have 155 plus 25 equals, 5 plus 5 is 10, carry the 1, 5, 6, 8, 1. 180 degrees total. So these A and B are supplemental, or they're adjacent because they're next to each other, and supplementary. So another word similar to supplementary is a supplement. A supplement is something like vitamins to complete nutritional needs. A supplement also could be if you don't have enough money. Maybe the government can supplement your income to make sure that you can pay your rent and buy groceries. Adjacent. Adjacent just means right next to each other. So these two pens, they are not adjacent. These two pens are now adjacent. Adjacent, not adjacent. Height. The height of a parallelogram is the perpendicular distance from the base to the opposite side. So my base, perpendicular, distance to the opposite side is my height. Flexible. Flexible means that something is easily bent or changed. So this protractor right here, I can't really bend it very easily. It's not flexible. However, if I take this piece of paper, I can flex it like crazy. It's easily bent. If you flex your muscles, then where the muscle moves up on your arm, that is showing that it's flexible because it easily moves. The Saxon lesson gives instructions to make a flexible model of a parallelogram to demonstrate how the shape can change even though the sides stay the same size. Okay, so what are the properties of a parallelogram? How do I know I have a parallelogram in front of me? Parallelograms are special quadrilaterals. Remember, quadrilaterals are four-sided shapes formed by two pairs of parallel lines. So square is everybody's favorite parallelogram because it has all right angles, everything is exactly the same size, everything is the same. No matter how you turn it, it's the same thing. A rectangle, these two lines are parallel, these two lines are parallel, but they're not the same size. A rhombus, these two lines are parallel, these two lines are parallel. This thing right here, these two are parallel, these two are parallel. So each pair of parallel sides is congruent, but the pairs are not always congruent to each other. So in these cases, congruent, 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 but not congruent to each other. These ones, all four sides are congruent, but on this one, these and those are not congruent to each other. So remember, congruent, we just learned 2 weeks ago, means exactly the same whether we know the number or not. So a square and a rhombus have all 4 sides are equal or congruent. So square, congruent all around. Rhombus, congruent all around. A rectangle and other parallelograms have 2 different sizes of their sides. Okay, so this right here is a drawing that kind of represents what the Saxon lesson was trying to have you do by building a model. If you have the supplies to build that model, please go ahead and do it. It's going to be fun. It's going to give you some hands-on math. If you don't have the supplies to do that model, don't worry about it. So if you change the angles and thus the shape of a parallelogram, you will change the area inside. So I started out with perfect 90-degree angles, and I made a rectangle parallelogram with 3 centimeters and 2 centimeter sides. My area is length times width, 3 times 2 equals 6 centimeters squared. Then I drew it kind of slanted sideways. I used a ruler to make sure it actually was the sizes I was claiming. So let me just show you. So this was 3 centimeters and 2 centimeters. So this one right here is 2 centimeters for that length and 3 centimeters for that length. So even though it's the same size on those lengths, this looks a little squished. It looks a little smaller. When I multiply, I would still get my 6 if I did this, but this is not my height. 3 is no longer my height. I need to measure perpendicularly from the base. It's sitting on that 2, so I'm going to call 2 my base. And then I had to measure up that way, which I ended up coming out with 2.5 centimeters. Again, that was measured. So 2.5 is my new height. So I did 2.5, or 2 5/10 times 2, and it comes out to 5 centimeters. So if I squish it even more, go from this to that, this guy looks really tiny on the inside. But it's still the same outside lengths. So I've got 3 still, and I've still got 2 over here. But I have to go from my base up into, up perpendicular from it, so my base, and then perpendicular. And that comes out to about 1/2 centimeter. So 1/2 centimeter height times 2 centimeters base gives me 1 centimeter. So all 3 of these parallelograms have a perimeter equal to 10 centimeters. 3 plus 2 makes 5, plus 3 more makes 8, plus 2 more makes 10. They all have the same outside lengths of 10 centimeters. And they all have sides of 3 centimeters and 2 centimeters. But the area changes as I squish it. So they're the same size on the outside, but they're actually smaller. They're different sizes. So the area of a quadrilateral. Remember, the area of a square or a rectangle is area A equals base times height. Area equals base times height. This is true for all parallelograms, but you need to figure out the height sometimes if your parallelogram does not have right angles. So in example 1, I'm asking to find the area of this guy with a side of 5.2 centimeters going diagonal, 6 centimeters base, and then our height of 5 centimeters. We're not going to use these outsides. We're not going to use that 5.2. We're going to use the one that makes a beautiful right angle. So 6 times 5 equals 30 centimeters squared. And that's pretty much all you need to know. Good luck with the work, and if you need help, find me on Zoom.